So, phase changes. What are phase changes? Well, phase changes are when matter goes from one state, being solid, liquid, gas, to another state, making it a solid, liquid, or gas in a different state. But where do those exist, and why do we need to know them, and why? Well, phase changes are all around us every day. So, say your mom went to the grocery store and she bought ice cream, and she went and stopped at a friend's house on the way home from the grocery store, and she realized, oh no, there's ice cream in my car. So she drives home as fast as she can and then puts it in the freezer, hoping that the liquidy, gooey, ice creamy mess will turn back into ice cream or something resembling it. Anyways, she puts it back in the freezer, and tomorrow, the next day, it's like almost ice cream again. It's just kind of awkward because it's been melted and then frozen again. That's an example of a phase change, from it going to a solid, to a liquid, and then back to a solid. Another phase change is your coffee pot every day. Every day when you make coffee, you put water into the back of it, hopefully. I don't know how your coffee pot works. And then when you turn it on, the water heats up and evaporates, and then at the top of the coffee pot, it condensates, and then after it goes from this liquid to the gas turns back into a liquid, drips on the coffee, and then bam, you have coffee. And also, have you ever thought about, like, if you had some lemonade with ice in it, and you leave it out and forget about it for a little bit, and then you come back to it a few hours later and try to drink it, it's all watered down and icky? That's because the ice that once was in it melted and diluted your drink a little bit, so it's kind of awkward tasting now, but it's still lemonade, and there's a phase change going on. Then, after you get past the whole real world thing, you have these things in science called phase change diagrams. How much fun are they? And this just shows any particular substance. This one, I don't know what it is, but it's a phase change diagram. And it shows you how, depending on the temperature and pressure, it will tell you what state of matter that one is. And there are 7 important words that we should know when we're dealing with phase change diagrams. The first one you should know is when something goes from a solid to a liquid, it is melting, and liquid to solid is freezing. Then you have the liquid going to a gas, which is evaporation. Gas to liquid is condensation. Then we have these weird ones down here that we didn't learn about in elementary school, so they're all really new to us and we have no idea what's going on. And that is the gas going straight to a solid and skipping the liquid phase. That's called deposition. And when something goes straight from a solid into a gas, it's called sublimation, and that also skips the liquid stage. Then the 7th word we should know is the triple point. At this point, not a solid, liquid, or gas exists. They all exist at the same time, which is kind of weird to think about because that never happens, but it's on the graph and we should know it. Like at this line, both liquids and gases exist. And same with this line, solid and liquid, and this line, gas and solid. Interesting. Anyways, we have to learn this for STAR because the state said so. So know your phase changes and solid, liquids, gases. And you know why that happens? That happens because when the particles speed up, say you have something that's frozen. All the particles are really close together and they're not moving very fast. So they're all still vibrating, but they're close together and they're not moving. And then when you add more heat, they can break apart and then it becomes a liquid. And they're all just hanging out, doing their own thing, and they're still kind of bonded together. But when you add them more heat, they turn into just crazy, and they're a gas. They're now a gas, and they're just moving all about because they have so much energy from heat or pressure, and then when they start to cool down again, they become gas. I mean, liquid. They become a liquid again, and then as the liquid cools down, it comes back to a solid, which is just hanging out here. And that's why. It's just how much pressure and how much heat is applied to any matter will change its phase, no matter what it is, because everything has everything has something like this, but depending on what type of matter it is, it'll vary, because your water freezing point isn't going to be the same as, say, your antifreeze freezing point. Your antifreeze freezing point is going to be a whole lot lower than 32 degrees Fahrenheit, 0 Celsius, because that's just the nature of its chemical makeup. So, learn your phase changes.